All right, so now we're going to start talking about rates of change and behaviors of graphs. Specifically, we're going to talk about the average rate of change of a function, which is really the same thing as the slope. We're going to calculate what's called the difference quotient for a function. This is a relatively minor thing in this class, but you're going to find if you go on to calculus, this is a very important concept, and it's going to form the basis of what's called the derivative in calculus. And then if we're given a graph or an equation, we're going to talk about where the function is increasing, decreasing, or constant, and also find relative and absolute maxes and mins from using a graph. To find it algebraically, you really need calculus. So we won't talk about that just yet. Wait till the next class, all right? Okay, so what do we have here? First up, we have the rate of change. The rate of change, of course, describes how an output changes relative to a change in an input. So this, at its most basic, is change in y over change in x. Remember that y is going to be our output, and x is our input, and so we're really talking about rise over run, right? And of course, f of x2 is going to be y2, f of x1 would be y1, so we've got f of x2 minus f of x1 over x2 minus x1, which is where we can really see that this is just slope, right? Except that when we talk about slope, we're usually talking about slope of a linear function, and with rate of change, it could be any type of function. So, but at calculating it wise, we're really just talking about dividing the change in the y values by the change in the x values. So for instance, we have this graph here, and we want to find the rate of change on the interval -3 to -1. So we've got -3 to -1, and we've got to look at what our function values are at those places. And it looks like we've got the point -3, 5, and -1, 3. So when we calculate that slope, we're just going to do, the rate of change. So sometimes I abbreviate that ROC. We've got our rate of change in y, so 5 minus 3, over -3 minus -1. So we're looking at 2, -3 plus 1 will be -2. So we're talking about a slope of -1. And we can see this, if I can maybe graph it, well, we can see that, and we're going over 1, down 1, over 1, down 1, so on and so forth. So we did calculate that slope correctly. Now, this function is not a linear function, and we can really see that if we look at the rate of change between the point over the interval 2 to 3. Okay, so if we look at 2, we can see that function, point there, we're looking at 2, 0, and at 3, looks like it's about 7. So 3, 7, and so again, we do the same thing. We calculate our rate of change as our change in y. And again, order doesn't matter so long as you keep your pairs in the same order. But we'll do 0 minus 7 over 2 minus 3. So we've got -7 over -1, thank you, which of course is +7, and we can see here over 1, up 7. We calculated that thing correctly, but I can't draw a straight line between those 2 points to save my life. Close enough. Okay. So we're, let's see, about at the 5-minute mark. So it's a good place to stop, and we'll do some more examples in the next video.